Hello everyone. Today we're going to talk about some vectors problem, and before that, let's do the recap for the last class. Recap on section B. Okay. So in the section B, we've talked about this one line. For example, this one line here. So we started from P, from Q. And then this is the direction, and then we give one vector A. Okay, so in this line, okay, in this vector, so how to represent this line? Okay, how to represent this line? So basically we use P, Q, like this. Okay, well the P is the starting point and Q is ending point. So we use this one to represent this vector, and then we also, or sometimes we just write A. Okay, and then this is for the direction. Okay, so basically they're talking about direction, right? Direction. So how about magnitude? How about this magnitude? In the magnitude, okay, we use not different symbol. We use this P, Q, and then this, or sometimes we just draw A. Okay. Sometimes we also use for this. We also may use this. Okay, but this most of the time we just use these two. Okay. So basically, and then we also talk about, okay, if in the Cartesian plan. So how are we going to represent this in the Cartesian plan, for example? So we just move these things to the Cartesian plan. In the Cartesian plan, there's something like this, P and Q, right? So this is the direction. So in the Cartesian plan, we're looking at displacement to the right. For example, this is y-axis. Displacement to right, and then it's going upwards. Displacement. So for example, in this case, so we have a 3 and 4. So then we will use a column. So we'll use the column vector notation. Column vector notation. So how we use that one? So basically we just say from P, Q, and then we will write in this way. So there always the x factors on top. So the x component always on top and y component always on below. So this is the way. So which means from P to Q. So there's 3 units of displacement to the right, which means this, and 4 units of displacement upwards. Okay, so this is how we. So basically, so from here we can see we're talking about meaning. We're talking about 3 items. The first one we discussed is the direction. So how to represent the direction. The second is magnitude. And last one is how we use column vector to represent at Cartesian plan. Okay, and also we also discuss. So basically, we also discuss how to find out this. Now we have these things. We have column vectors. So we also work out how to calculate magnitude. Magnitude basically equals to the A equals to the 2 sides, right? So from 3 squared plus 4 squared, then we can work out is 5. So basically, how we work out these items? So let's check out this thing here. And here we use the Pythagoras theorem. So which means this is right angle. Okay, same than this. So for example, here's Q, here's P. So this is the direction. So it's A, and then we find out this is 3 unit, this is 4 unit. So we just apply the Pythagoras theorem. We find out whichever in the right triangle. So we can find out A square equal to 3 square plus 4 square. So we can find out A, in our case, is that this, right? So which is 5. Okay, we can work out. We can work out 5 here, right? This is how we come up this magnitude. How we do the calculation. Okay. Right, just transfer here. Let me just transfer this thing here. Transfer the whole thing here. So we have work out. So in this case, so we have the P, Q, this direction, or A. Magnitude we'll put in this way, right? Or this, right? Of course, the vacuum. So basically, X and Y, right? Okay. Now from calculations, we also know that the magnitude here equals to x squared plus y squared, right? Okay, that is what we talk about in the section B. Okay, we have this, basically we have this 1, 2, 3, 4 concepts. First one, direction. So how we represent the magnitudes, what the symbol looks like, and then in the Cartesian plan, so how we use the column vector to represent this, we have y, x and y. So just remember, this x and y is the displacement from the x is displacement from to the right, and y is displacement upwards. And then we also use the Pythagoras theorems to find out, so what's the magnitude based on this right triangle formula. Yeah, okay, that's a recap. So here comes the example 1. So we have example 1. Okay, so we're going to draw some vectors in the Cartesian plan. So in this plan, this is y-axis, this is x-axis. So basically we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? Okay, so this is the origin. So okay, let's look at, so the first one, so we have that is the A, that is the B is 5, 2, 3. This is here. And the next one is the 3, 2. 3, 2 is here. And the next one is 4, 4. It's here. So this is A, C, D, and then we also have 2 to 4. Starting from 1, right? 2 to 4. Okay. Direction. Now we have E, we have F. This direction, right? Okay, so we have another one from 3 to 5. Which means this is the direction. This is where to go here. Alright. But just take note. It's not direction, this is the direction. Okay. Okay, next work out right on the column vector. The column vector. So basically, okay, so let's give the first one, okay. It's A, sorry. A to B equal to column vector A move to B is the 2 displacement 1 2, and then moving up is 1. Okay, so this is one of the ways. So 1 2 displacement or 1 displacement up. So that's one other methods to calculate this column vector support A to B. So that's another way we're going to discuss in the next class, but I can just share with you first. Okay, for A in the coordinates, what's the coordinate? So 1 to 4, right? And B is what's the coordinate? 3 to 5. Okay, so in this case, so because it's moving from this coordinate to this coordinate, so we just use the final, the ending one minus the starting one. So which means AB equals to the ending coordinate minus the beginning coordinate. So which we get 1 to 1 as well, right? So this thing I'm going to discuss later in the next class. I just share with you how we can calculate in this way. Yeah. Okay, very fast. Let's move on to the next one, B. So let's look at C to D. Okay, C to D typically is the same thing, right? So horizontally, so basically C to D is 2 displacement, and then going up is 1. Okay, C is what? E to F. E to F horizontally, you just move 4. So vertically, nothing, 0. 4 0. Sorry, 1 2 3. Sorry, it's 3 0. Okay, let's look at the C. So E F. Okay, horizontally from E to F to the right direction is 1 2 3, so it's 3. Vertically, nothing, 0. Okay, next look at the next one. Next one, G to H. G to H is moving downwards. So they move towards left. How many? 1 unit, 2 unit is 2, right? So because they're moving this to the left, so it's minus. Okay, going to this direction is minus. Anything going to this direction is minus 2. And then going at the same time we're going downwards also minus, right? So downwards is 1, so it's minus 1. Okay, so we get out. Okay, the last one is A to A, because from point A, coordinate A, I move the coordinate A, basically it didn't move, it's just in the same locations. It's 0 0, right? So we get all those answers. Okay, from here, So basically, we can find out some things very useful for futures coordination calculations. So we can find out what the difference between these three items. So from here we can see A, B in terms of column vector equals to C, D, right? So because these two values are the same. So from here we can find out something very interesting is they have from diagrams we can also see the same thing. The first one is what? They have the same direction. The second thing is what? They have a same magnitude. And they are also parallel to each other, right? So this is very important information here. So basically we will share in our next class, but I just tell you in advance. So we have these findings. Okay, this is very interesting finding we can from here. Same direction, also parallel, at the same time the magnitude also same. Okay, let's look at next one. How about the GH? GH basically they are also parallel. Okay, they are also parallel. Of course, my drawing is not that good, but they are parallel, but in the different direction, right? So, but they have one same things. Their magnitude is the same, but the direction is different. So just talk about this one here. AB equal to CD, but it's minus GH. The minus is because the direction is different, right? So they have the opposite direction. That's why it's a minus. So, but they have the same magnitude, and they also parallel to each other. Okay, but anyway, we're going to discuss about all those things in the next class. Okay, so let's see. Just remember this. Okay, that is example one. So that's one try. So it's similar things in our class. Okay, when you go back home, you maybe probably can just try it. Okay, number one. Okay, you can try it yourself. Okay, thanks for watching. We stop here today. Thank you very much.